Analytical geometry, because I'm seeing that many of you have not done this yet. And Lerato, you came right on time because we haven't started just as yet. Okay, so analytical geometry is basically we're taking geometry that we know and we're taking coordinates like on the Cartesian plane and we're putting them together. Now, normally, if you're going to look at studying things like geography, if you're going to ever work at in an international space station, if you're ever going to look at how they map out roads, how to look at infrastructure, anything of that sort, you're going to use analytical geometry. It's used for things like Google Maps. Okay, those things that we had to learn in grade 4 about the Greenwich Meridian and the equator and the lines of Capricorn and Cancer, all of these things are mapped out by analytical geometry. And that's why this particular section of maths is so important, because it makes up this part of mathematics. It's just going to be at a bit of a little bit more difficult scale when you get to like university and the such. Okay, but this is the foundation. We're about to learn the basics of it. And the first thing that we're going to learn today is we're going to learn about the distance formula. Bonolo, I'm going to ask you to just hold that question for me, my sweetie. I'm going to be with you in just a second. I just want us to get a handle on the distance formula quickly. All right, so if I have 2 points, all right, if I have 2 points, I'm quickly going to draw 2 points. Here's one, and here's another one. And let's say, for instance, this point is 1, 1 over here, and this point over here is 5 and 8. All right. Now, if I asked you, how far away is this point from this point? We can easily say that if I want to get right underneath this point, I need to walk 4 units this way because my x coordinate tells me so. This is my x and this is my y. This is my x and this is my y. So if I want to go from this x coordinate of 1, I'm going to go back, Tabo, just give me a second. All right, if I want to get from this coordinate of x coordinate of 1 to that x coordinate of 5, I need to move 4 units in this direction, right? And to get from this y coordinate of 1 to this y coordinate of 8, I need to move up 7 units, right? Now, and then Amohelang says, don't you need to use the special angles? Not for this, my sweetie. We're going to learn something completely different. Okay, just hold on. I'm going to explain, Liko. Just hold on for me. All right, so we know that if this is home, and if this is the Woolies around the corner from home, or the Pick and Pay or the ShopRite or whatever it is, then we can't go straight through people's houses to get there. So if this is my street, then I know I need to drive 4 kilometers this way or 400 meters this way, and then 400 meters that way. But that's not the question I'm asking. What I'm asking you is, in terms of your location, in terms of where you are, how far is the shop actually from your house? So we need to figure out how to get from here straight to there, even if it means going through the houses. Now, if we look at the units, if we look at how far we have to move right and how far we have to move up, that's easy enough. But if I said that I moved this way and then I made a straight perpendicular line that way, if I look at this, guys, what kind of shape have I just created over here? Tell me in the chat, what kind of shape are we looking at? Be very specific. I knew Baronix, I knew somebody would say that. I need you guys to be specific. It's not just a triangle, it's a yes, pair. Good, good. It is a right-angled triangle. Excellent. It's a right-angled triangle. But now I know that this side is 4 units, and I know that this side is 7 units. Does this right-angled triangle have some sort of formula that we've learned before that can help us figure out how far this side is? Anybody? Somebody? Yes, that's it, Princess. Well done. Yes, Benjamin. That's it. The theorem of Pythagoras. Okay, so when we're looking at the distance formula, guys, let's have a look quickly. Here it is. If you need to take a screenshot, this would be the perfect time. All right, we need to look at Pythagoras. Now, what this formula for Pythagoras is doing, I'm just going to clean this up a little bit just so that we're not looking at like 6 million lines. Okay, yeah, I'm gonna do this. Take all of this lovely stuff away and make it look nice. Okay, there's a 1 there. Okay, now if we're looking at our dot for 1, 1 and our dot for 5, 8 over there, I know that to get from 1 over here to 5 is the same as if I said, because I know this is my x coordinate and this is my x coordinate. I can then use the idea that if I move from here to right underneath this, this is 4 units. I can still go 5 minus 1. 5 minus 1 is going to give me 4 units, right? Because I took the x over here and I minus the 1. So this is what the formula is actually doing. It's saying if this x value is 5, I'm going to minus this other x value over here, which is 1. And that's going to give me the 4 units that I want. But because of Pythagoras, I need to square it. Right, and then I need to add, I know that to get from here, here's my x coordinate and my y coordinate over here. To get from 1 to 8, I need to add 7. But what it's actually saying is 8 minus 1, but I still need to square it because of Pythagoras. So I would go then 8 minus 1 squared. And then because we know that it's Pythagoras theorem, this part would also be squared. To get rid of that squared, we would find the square root. So in order for us to use the distance formula, we first have to decide which of our 2 points is going to be x1 and y1, and which of our other points is going to be x2 and y2. And then we can figure this out. I want to see if you guys can do this for me, right? We're going to go. I'm going to call this point over here, down here, this point that we have 1 and 1. I'm going to call this point x1 and x2, and I'm going to call, oh, sorry, x1 and y1. Yo. Teacher Nels, help me out here. Don't leave me hanging. All right. Okay, I'm about to make it simpler. Okay, this part over here is going to be x1 and y1, and this part up top here is going to be x2 and y2. So we're going to put this into a formula, and we're going to find the distance between them. Right, so we're going to go, the distance between them is equal to the square root of, my x2 value is 5, so I'm going to open brackets, 5 minus, and then x1 over here is 1, all squared. Okay, plus my y2 value is 8 minus my y1 value, which is 1, all squared, right? And then I want you guys to pick up your calculators, and I want you to substitute all of this for me, because I now know that D is going to equal to the square root of 5 minus 1 is 4 squared, plus 8 minus 1 is 7 squared. And then you punch that into your calculator and you give me an answer. See, Kimokukro has already given me an answer because she just picked up a calculator. She's like, nah, ma'am, I can do this. Okay. Tell me what you get, guys. Put your answer in the chat. Okay, somebody says they got 28. I'm not sure how we could have gotten 28, Atlehang, because you still need to take the square root of what's happening inside. There we go. Appreciate says the square root of 65. And I'm seeing most people saying the square root of 65. Excellent. This is the square root of 65. All right, so we don't really have to go into a lot of detail about it. I'm just explaining where the distance formula comes from. What we have to remember is the actual formula over here. Okay, this beautiful formula that ma'am's written on the screen. So I want you guys to write it down somewhere on your page as you're going. Okay, write it somewhere on your page because you're going to refer to it quite often in this lesson. Okay. All right. Hama, I'm going to say hi to you, my sweetie, and then you're going to have to do something for me because I need to hear your voice today. How are you doing?
Yo, ma'am, I'm good. Sorry,
What's
I was
up?
just going to ask, what are we doing today?
We are starting analytical geometry today, and this is the distance formula that we're learning.
Okay, so the distance formula, ma'am, could you just do a quick re-explanation of it for me, if possible?
Okay, cool. I'm going to ask you though, we're going to be doing this together. It's not just going to be me doing it.
Yes, ma'am.
All right. I'm going to make it easier for you. We're going to take, I want to calculate the distance between point A and point B. So I'm going to take point A and I'm my x1, and with my x1 needs to come y1 as well.
Y1. Okay.
Good. So if I take B and I call the x value over here x2, what does my 8 have to be?
Y2.
Excellent. Y2. So we're just going to substitute in the formula. We're going to go AB is equal to the square root of, I would like you to finish up the sentence for me. Open brackets.
Open brackets minus 2. No, sorry. No. 3 minus 2.
Good. 3 minus -2. Good. Close brackets. And then what must come?
Squared.
Good. Squared plus.
Okay. Plus y2, which is 8. Minus -4.
Good. Minus -4. And what's left?
Squared. Close bracket squared.
Good. Close bracket squared. So I don't have to recap because clearly you've got the right answers for me today. I'm very
Okay, ma'am. Are you sure? Because like I'm really doubting myself.
No, absolutely. Look, okay, the only thing that we're going to have to do in the middle here is that the minus and the minus will give us a
positive.
Positive. Good. So I have 3 plus 2, which is actually 5 squared.
Yes.
Plus 8 plus 4 is?
Yeah, quick maths. Isn't that 16? No, 12. 12
squared. That's it. And then you just need to punch this into the calculator and give me an answer. Okay. Punch it into a calculator for me. Everybody else,
oh.
You're very welcome. You can't go. You must give me my answer. Where you go?
Yeah. What is it? Okay. 12 squared. Isn't it 120 something? It's 120 something. No, 144. Sorry. I think it's 144.
Good. And the 5 squared is 25. So you need to put, Kim, tell me what goes in there. 25 plus 144 will give us?
169.
Good, 169. But we still need to take the square root of that. What is the square root of 169?
Yeah.
And use a calculator. We allow calculators in this section. Don't stress.
So 13. I'm seeing answers in the chat. I'm trusting people here.
Yes, they are correct. It's 13. All right. So the distance between A and B is 13. Look, you did that so beautifully. Wow. Excellent.
Thank you, ma'am.
Excellent. It's lovely to see you, my sweetie. Guys, Kama literally helped us like put the foundation stone at Watobe. She's our veteran Watobe of note. All right. Hi, lady. How are you doing, my sweetie?
Hi, ma'am. Ma'am, I'd just like to ask, I punched the first part of the formula by the 3 minus -2 squared in the brackets, and ma'am, my calculator gave me 25. So ma'am, I would just like to ask, like, where do you get that 25? Like, how do we get there?
Okay. All right. So you agree with me that a negative and a negative will give us a positive? Yes?
But yes, ma'am, I saw that. But what confused me is the fact that there's like no times there or like an indicator that it was multiplying.
Yes, but what we actually have here is 3 plus 2, which is 5 squared. What is 5 squared, my lady?
25.
5. So that's where your calculator is getting that part from.
Okay.
Making sense?
Yes, ma'am.
Okay. Excellent. All right, my sweetie. Awesome. Palisa, I will answer that question at the end of the lesson. Okay, Bonolo, what's up?
Hi, ma'am. How are you?
I'm good, thank you. How are you?
Fine, thanks. I just have a question based on the formula of distance. Please do correct me if I'm wrong, but with dealing with parallelograms, right? If I'm not mistaken, can we use the same formula, just a thing of instead of x2 minus x1, can we say horizontal length plus vertical length?
Squared.
Yes, squared.
Yeah. But absolutely. The difference in the horizontal length and the distance in the horizontal and the difference in the
vertical
length, but we need to square it because the idea behind the distance formula comes from the Pythagorean theorem.
Yes. Okay, perfect. Thank you. Just wanted to make sure.
No problem, my sweetie. Yes, absolutely, we can do that. In fact, I think Bonolo's ruining it because I've put parallelograms in my quiz for this week. Okay, so thanks, Bonolo, for showing everybody how to, you just a whole cheat code. Can't believe you. All right, so I hear Thabo asking, and ma'am, thank you so much for explaining that. I hear Thabo asking, how do we know which one is X1 and X2 and which one is Y1, Y2? It doesn't make a difference. Okay. I can call this one X2 and this one X1, but the only thing that I need to make sure I'm doing is that if I call this X value X2, this one must also be Y2. And if I call this one X1, this one must also be Y1. I can't switch them around. Okay, so I can't decide that this is X2 and this is Y1, and then this one is X1 and this is Y2. I cannot do that. I can't do that. What I can do is choose whichever one of them is X1. The corresponding Y value must be Y1. Okay, so you can't switch them around. Okay, I hope that's making sense, Thabo. Hi, Kama. What's up, my sweetie?
Sorry, ma'am. Do we ever deal with parallelograms in the Cartesian plane? Aside from like triangles?
Well, there are triangles. You can put pretty much any shape on a Cartesian plane, to be honest. But we're going to be focusing on the types of shapes that we've learned about. Okay.
Okay. Thank you.
All right. Okay. You're very welcome, my sweetie. Somebody's like, how do I do the hand wave thing? Buhle, I don't know how to help you there. I don't know how to help you. I don't know what the hand wave thing is. All right. We're going to try some of these examples ourselves. Okay. There are quite a lot of them. We're not going to focus on all of them. I want you guys to do number 9, number 10, and number 11 for me. And once you're done, do not pop your answers in the chat. No answers in the chat. What I want you guys to do is I want you to put the fire emoji in the chat for me. I'm going to give everybody 5 minutes. I'm going to be nice and give you the distance formula again. And I saw somebody also asking, don't we write D for distance? Now, imagine if we had a Cartesian plane and there was a line called AB and there was another line called EF and they said calculate the distance and you just said D. Which line is it? Which line is it going to be? See, we're not going to be able to know. So we're going to name the line according to how they've named it. So we're going to say AB is equal to whatever it is that they want me to calculate. And then when I calculate for the distance of E and F, I will then write EF is equal to whatever it is. Okay, so we're just expressing the name of the line. All right, so the distance formula says D is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Okay, take it away, guys. Once you're done, fire emoji. I saw somebody already put a fire emoji and I don't believe it. I don't believe it. Sviso says, can you please repeat? Okay, Sviso, if we look at question number 9, yes, Palesa. Okay, if we look at question number 9, Sviso, they tell you that the point here is A, there's a point A, and there's a point B. So when you put this into the formula, you're going to write AB is equal to the square root of, and then continue with the sum. Okay, and then you can choose, this can be x1, and this is y1, and this over here can be x2, and this can be y2. You can choose, or you could do it the other way around. Everybody's going to get to the same answer. In fact, I would encourage some of you guys to do it the other way around, because we're going to end up with the same answer. Okay. Ohans is like, I'm already done, guys. You guys are wasting time. Okay, Z, what do you mean you don't understand what's going on? Yes, quickly, just the ones in purple. Okay. I almost said new Tsiamo's done. Tsiamo, I don't know. We'll figure out a nickname for you guys, but one of the Tsiamos is already done. No worries, Junior. Welcome. The new one is done. Zwanga, thank you so much. All right, guys, remember we're just substituting in the formula, into the formula. Okay. Mamelo's also done. Anesipo's also done. Rorisang. Sfiso's having problems. Sfiso, if you're having problems, just wait until we go through the questions and then you'll see where we may have lost each other. Okay, Kunhle is done. Karen is done. We'll give everybody else a couple more seconds. Okay, remember, those of you who are putting the fire emoji, you've done all three of them. You haven't just done the one. Oh, Mawande, I'm so sorry. Mawande, hello, welcome. Okay, we'll give you some time, my sweetie, it's fine. And the other Tsiamo is also done now. Kanyisile is done. Yes, yes, Tabo, just those three, 9, 10, and 11. Hi, Busisiwe.
Hi.
Hello, my sweetie, what's up?
I'm having a challenge with my calculator. It's on DEG. It's on
It should be.
RAD, I mean.
Okay, Teacher Nels, Teacher Nelly's gonna, she's going to message you now. Okay, she's gonna private message you and she's gonna help you to switch it back to DEG, okay?
Yes, ma'am, I'm using a sharp calculator, not a Casio.
Oh, a sharp one, all right. Ooh, okay, that might be difficult, but I'm sure there's a shift button somewhere there, okay?
It's second function, I think.
Okay, yes, that one, second function. So it's gonna be somewhere there. I'm gonna ask Teacher Nelly to deal with that in just a sec. Okay, she's gonna DM you now.
Thanks.
All right, thanks. Hello, Jonathan. Jonathan's here. Hello. Nolwazi's here. Kama, what's up, my sweetie?
Ma'am, sorry, I'm a little confused. So like, I know that when you've got a third sign and a squared, right, they cancel each other out. So like now I'm a little lost here.
Okay.
It's not make sure.
Okay, what answer did you? Which answer did you?
So like
get?
I was
did
doing
you
number
get
10,
the answer
right? Yeah, I think I did. I was doing number 10. And I just got a little lost, like majorly lost. So I don't want to say a little, like I got majorly lost. Because like I put in the x minus 2 minus x1 thingy, the formula. And like I did everything accordingly, but like I'm still lost because like I'm confused on whether or not the third sign disappears after we've like done the squaring. Oh.
All right. Okay. So I'm gonna show you as we go along. It's always gonna be easy, especially you have a Casio calculator, yes?
Yes, I do.
Okay. To avoid any issues, just start by clicking the square root sign. Just start there. You're already going to click the square root sign and then put everything, you know the way we would write it out. You would go
yes ma'am
minus 2 plus open brackets 15 minus 3 all squared. Punch that into your calculator exactly the way it looks. Click equals, put your answer down. Okay, because if you start trying to do it bit by bit, it's going to start to dribble us somewhere, and we don't want to get lost in the process. So
yes,
calculator exactly the way that it looks, and it will spit out an answer for you, and that's the answer you write down. Okay.
Thank you so much.
You're very welcome, my sweetie. Keep the questions coming. I love them. Okay, that's okay, Atlehan. That's okay. All right, let's look at these answers very quickly. Okay, so for number 9, okay, I know that AB is equal to, and I'm going to open my square root sign. like that. And then I'm going to go onto my calculator and I'm going to take my x2, which is 6, minus my x1, which is 0, all squared, plus x2, which is 8, minus y1, which is 0, all squared. Okay, and this is equal to the square root of 6 squared plus 8 squared. Okay, and this is going to give us, if you punch it into your calculator exactly the way it looks, it's going to give us 10. Give me a thumbs up if you got 10 as an answer. Kimotoko says yes. Bukhe, we're doing analytical geometry. Unati, you did not get 10. And that's a little worrying because this is literally a plug and play type situation. We're just punching it into our calculators and getting the answers that we wanted. Yes, Tabo. Oh, Mfundo says, Ma'am, I got 100. It's because you didn't put the square root sign in, my sweetie. You still need to square that 100. Okay, hi, Tabo. Oh, no. Okay, Tabo's gone. Mamelo, what's up?
Hi, ma'am.
Hello, my sweetie. What's going on?
I made a mistake from the start. All my answers are going to be different because from the brackets of 0, 0, I made x1 and x2 when I was labeling.
Oh, you made these x1 and x2.
Yes.
Oh, but sweetie, we need to remember, these are actually on the Cartesian plane. Remember when we did equations of straight lines in grade 9? We always gave you coordinates like this, 2/4. And we said this is the x coordinate and this is the y coordinate. We're doing the same thing. It's just that we're naming one x1 and the other one y1. Okay. Okay, I want you to try the next one with me. Okay, don't go away. Do you have your calculator in your hand?
Yes.
Okay, excellent. I want you and me to do this next one together. All right. So, Mamela, I want you to tell me, see -2 and 3. What are we going to name these ones? What can we name them?
So our -2 is going to be x1.
Excellent. And my 3 would be?
Y1.
Good, y1. And then for this one over here, 3 and 15 would get?
Our 3 is going to be x2.
Excellent. And my 15?
Is going to be y2.
Excellent, y2. All right, this line is called RS. So we're going to go RS is equal to the square root of, and I'm going to open brackets for you, but I want you to finish up for me. What is my x2 value?
X2 value is 3.
Good. And then what comes next?
Mm.
Look at the formula. Look at the formula.
Okay, then we minus x1, which is -2.
Good. So you agree with me, Mamela? I'm going to get 3 minus -2. Yes?
Ma'am, let me check first.
Okay, okay, hold on. So the formula says 3 minus x1. Yes, x2 minus x1. But x1 already has a negative with it. Do you see that?
Yes.
Good. So that means I'm going to...
going
What's my answer going to be?
5.
Good. Yes, because I'm going to get 3 minus -2. And that's going to give me 3
Positive.
plus. So now you're seeing it. But I'm not done. If I close bracket, what do I still need to do?
We need to move to the equations of y.
Oh, no. What must this bracket have? It must all be...
Or the square root. The square root.
The square, not the square root, the square. There's a difference between the square and the square root. Okay. Plus, now we can do the y. I'm going to open brackets. Tell me what I'm writing for y.
Y2, which is 15. 15.
Good, 15.
Minus y1, which is 3.
Good, and close brackets, and then?
We should have the square.
Good, squared. All right. So we're going to go ahead, and you've already said to me that this is going to give us 3 plus 2, which is 5.
5.
Squared. Right?
Yes, ma'am.
Plus, what about 15
12.
minus?
12
Good.
squared.
Punch that into your calculator. The square root of 5 squared plus 12 squared. What does your calculator give us as an answer? Everybody else, pop your answer in the chat for me.
13. It's 13.
Good. 13. Good. That's the answer I was looking for. Mamelo, you did that so beautifully. We were just a little bit confused, but I hope we're on track now. Are we together?
Ma'am,
Yes.
like for the first thing and the second thing up to the third answers, I did the same thing, but in the second term, which is 10, number 10, I got 13 also.
Okay. It is possible for you to get the correct answer using the wrong method. Okay, it is possible, but this is quite nice because we are going to get the correct answer every single time. Okay, and if you get the right answer but use the wrong method, I unfortunately can't give you the marks there when we're doing analytical geometry. So we need to use the formula the way it's going. Okay. All right, I see somebody saying, ma'am, what does RS stand for? Our first X point, the 1 points are called R and the other points are called S. So the point itself, the coordinate is called R and the other's called S. So when we name the line for the distance, we call it RS. Okay, if we look at this next one over here, if we look at number 11, I've got M over here, which is the coordinate 1 and -2, and then I've got N over here. So when I ask you for the distance of MN, you're going to go MN is equal to, and then you're going to give me an answer. You guys can pop your answers for this one in the chat for me. Okay. All right, everybody's saying 17. We're quickly going to check if that's correct. And then I'm going to give you guys a bit of a challenge question. All right, MN. All right, let's go. MN. And for those of you who are like, how on earth did we get 13? Okay, let's look at the order in which we need to do things. All right, I'm going to go MN is equal to the square root of, and I'm going to choose M as my X1 and my Y1 and my N values as X2 and Y2. All right, so I know my formula says X2, open brackets, X2, which is 9, minus X1 minus 1, all squared, plus, open brackets, Y2 is 13, minus -2, all squared. Okay, this is going to give me 9 minus 1 is 8 squared, plus 13 minus -2 will give us positive. So 13 plus 2 is 15 squared. 15 squared. And then we're all just going to punch this into our calculator. That's going to be what? 64 plus 225. And that should give us about 289. So my answer should be 17. All right. I don't know how we got the square root of 241, because I know the square root of 241 is not 17. Okay. Kemutlukru says, write the formula before substitution. Yes, it can help 100%, because after you've named your X1, Y1, X2, Y2, it makes it a little bit easier for you to be able to understand. Now, I want everybody to tell me in the chat, on a scale of 1 to 10, 1 being, ma'am, what in the world are you doing? And 10 being, I got you, ma'am. This isn't even, why are we just playing around with easy things here? Okay. Who said girl 7? Who was that? Was that you, Kama? I saw that. A girl, a solid 7. I'm at a 7. Somebody said 9.9. Mohomotsi, where did we lose that 0.1%? I need to know where my 0.1% went. Okay, I'm seeing a lot of 8s and 9.8s and 9s and 7s and 10s. And Licha's like, okay, yeah, 10. All right. I don't particularly think this is difficult, because we are just substituting into the formula and getting an answer. But if you are stuck, like Ramoretswe is stuck right now, I need you to tell me exactly where I lost you. Okay. Hi, Nolwazi.
Hi, ma'am.
How are you doing, Sweden?
I'm fine. How are you?
I'm excellent. What's up?
Ma'am, I'm still confused on all the questions because I do not understand why are we squaring, because I got all the answers incorrect.
Okay, all right, my sweetie. Remember, I don't know if you came in just a little bit late, but the reason we're squaring is because of Pythagoras. Remember the Pythagorean theorem that says a squared is equal to b squared plus
y squared or x squared.
Or c squared. Yeah, right. This is Pythagoras. So we're actually using the Pythagorean theorem. So we're taking this one and we're squaring it, plus this one and we're squaring it. The only difference is because this is a squared, to get rid of that squared, how do we get rid of the squared? No, Lwazi, we need to.
Which squared, ma'am?
This one here.
You need to square it.
Good, we need to find the
square or
square root.
substitute.
We need to find the square root, right? Let's
Yes,
say
ma'am.
if I had a question, my question was x squared is equal to 9. How do I get rid of the x squared? I need to find the
The square root of 9.
good. So now if we look over here, Nolwazi, I've got a squared. How do I get rid of this a squared? How do I get rid of the squared? I need
To find the square root.
good. So I would find the square root of this side and of this side. So this one will cancel. Therefore, a is equal to the square root of this side. And this is what we actually have in the formula. Okay. We've got the square root of this thing squared, of this part squared, plus this part squared. And that's exactly what we're doing. We're taking the square root of my x values squared and the square root of my y values squared. So we're actually using Pythagoras. Do you see that?
Yo, ma'am, you know, once you start including the x and y's, it becomes difficult.
Okay, all right. So what we're actually doing is called a multi-step question. Okay, it just means it takes a few more steps to get us to the answer. Okay, we're gonna try
Okay.
12 together. Are you ready, Nolwazi?
Yes, ma'am.
We're gonna try 12 together. All right, let's look at the formula. Remember what the formula says. I'm gonna erase some of this because we've already done these questions. All right, the formula says I'm gonna take x2 minus x1, right? And I'm going to square it
Yes.
plus y2 minus y1 squared. And we're going to take the square root of this whole thing. Agreed?
Yes, ma'am.
Okay, good. So now I want the value of EF. So we're going to say EF is equal to, and then we're going to put the square root sign. Good. Now I'm going to take E, the values of E, and I'm going to call this x coordinate x1. And if this x coordinate is x1, what is this y coordinate going to be?
It's going to be y1.
Good, y1. What about these other ones?
Which one, ma'am?
The ones for f.
It will be y. It will going to be x2 and y2.
Excellent. Good. Okay, so we're following each other. All right. So I'm going to open brackets and I'm going to take my x2 value. How much is my x2 value?
X2 value is negative 9.
Good. So I'm going to go negative 9 minus, what is my x1 value? Because I need to minus my x1 value. Minus?
It's minus 12.
Is it minus 12?
It's negative 12.
Good. So I'm going to go negative 9 minus negative 12. You agree with me?
Yes, ma'am.
And then I'm going to close bracket. What must I do then? I must
Add plus.
Before we add, whole bracket needs to be
And you square.
good, square, good. Plus, open brackets. What is my y values? What is my y2 value?
Y2 value is 6.
Good, 6. Then finish up for me, 6.
6 minus y1, which is 2.
Good, 6 minus 2, and then close brackets, and then
Square.
that's it, square. All right, now we're going to clean it up just a little bit, my sweetie. Let's clean up. Okay, so do you agree with me that a negative and a negative will give us a
positive?
good? So this is going to be positive. So can you tell me, Nolwazi, what is negative 9 plus 12? Oh my goodness. Okay. Nolwazi, are you still there?
-9 plus 12. It's 3, ma'am.
Good.
Positive
3 what though?
3.
Positive 3, but I've still got to square, right? I still have the square on
Yes,
the
ma'am.
outside. So this is actually 3 squared plus, what about 6 minus 2?
Positive 3.
6 minus 2.
It's 4.
What's 6 minus 2? Good. 4 squared.
6 minus.
Okay.
So
Are
ma'am,
you
I
still
was
with
asking
me?
if does the squared apply to all the numbers inside the brackets?
Yes, it must. Okay, and then I'm going to take the square root of this whole thing. Okay, I want you to just punch it into your calculator exactly the way it looks. So I want you to go and punch on your calculator, click on the square root, take out your calculator, go square root of, and then write 3 squared plus 4 squared. And then click
It's
equals.
equal to 5.
5, good. So our answer is actually 5.
Okay, ma'am, thank you.
Okay, making a bit more sense.
Yes, ma'am.
Excellent. All right. Okay. Kimotlutu was done with all of them. As we were going through that one example, Kimotlutu did the rest of them. Excellent. Well done. All right. I saw somebody say, ma'am, I'm still confused. Okay. Unkemetsi, you need to explain to me what is confusing. Okay. We need to not lose each other. Okay, so I need you to explain to me, ma'am, this is where you lost me. All right. I hope I'm saying your name correctly. I don't think I'm going to. Is it Lillian? I hope it's Lillian. And I hope the first part is your surname. Hi, Lillian. Can you unmute for me?
Hi, ma'am.
Hello, my sweetie.
Oh, ma'am, this whole thing is killing me.
How is it killing you? Is it because of the difficulty? I don't think it's very difficult. I think we just need to follow the steps, my sweetie.
Maybe just because we've done it though, but I'm coping.
Okay. All right. That's okay, my sweetie. What I want you to do is I want you to take a screenshot of what I have on my screen. Okay. And then I want you to go and try 13, 14, 15, and 16. Okay. That's your homework for today. And I know you're on holiday, so you have no other homework. I already know. Okay. Okay, so you're going to go try these. And if you're stuck, the recording for this lesson will be on our website by tomorrow. So you can quickly have a look at it by tomorrow. And before Wednesday's lesson, you guys will be top notch. All right. Okay, no worries, Lesero. We'll have a look at that. All right, we're going to take a screenshot quickly. I want us to try a question. I know it's going to be a little bit difficult for some of you, especially if you don't understand the concept that we've just done. But for the rest of you who understand what is happening, I want you to listen up because we're going to have a bit of a conversation. Okay, I'm about to algebra your lives. Okay. I know, Nolwazi, sometimes that happens. All right, let's think a little bit outside the box. For those of you who had trouble with the other stuff, I need you guys to focus on those questions. Don't look at these questions that we're about to do because it's going to confuse us quite a bit. All right, now it says here, this question over here that we've got says, the distance between points 1, 2, we're going to call this one A, and points 16, P is B, we're going to call this part B, is 17. So they give us the distance, the answer to the distance, right? And they say, find the possible values of P. Now, if we look at our distance formula, okay, I'm going to draw 1 and 2 quickly. Okay, this is point 1, 2. 1, 2, and then we know that our x value is 16, so it's going to be a lot further than that, I think. Let's just say Let's just say 16 is somewhere over here. Now, there's two things that could possibly happen. If this is my point 16, right? That's it. Princess has got it. That's it. If this is my value 16, if I want to measure the distance, I don't know what my y value is. They haven't given me my y value. They're saying that my y value is p. So I know that from here, my two values, which I'm going to get two values, my values for 16 can either be somewhere along here or somewhere along there. All of them will have an x value of 16. It's the y value we're looking for. So we know that our distance formula will say AB is equal to the square root of, and I'm going to open brackets. This is my x1 and my y1. And this is my x2 and my y2. And I'm going to go x2, which is 16, minus x1, which is 1, all squared, plus, open brackets, y2, which is p, minus y1, which is 2, all squared, right? Now, they tell me that AB is actually equal to 17. So I'm going to go ahead and replace my AB over here with the answer they've given me. They've told me that this is 17, right? And what we're going to do is we're just going to do a little bit of algebraic equation mathematics until we get to the answer of P. Now, I want P, and P happens to be stuck inside of a square root. How would I get rid of a square root sign, guys? What would I do? How would I get rid of a square root sign? Anybody got any idea? This is like, not algebra. Good, yes, Kuche, that's it. We would square. Good, we would square. We would take the whole square of this, and then we'd also have to take the square root of this, or the square of this side. Okay, not the square root, the square, right? Now, I know that the square of 17 is 289, which is equal to, now the square root will get rid of the square, or the square will get rid of the square root, right? So what I actually have left on this side is 16 minus 1 squared plus p minus 2 all squared, right? I know that 16 minus 1 is 15, so I've actually got 15 squared. I'm going to continue. 289 is equal to 16 minus 1 is 15 squared plus p minus 2 all squared. What is 15 squared, guys? I want to replace 15 squared. What is 15 squared? 225. Excellent. All right. Thank you, Teacher Nels. Everybody just answered the poll. 289 is equal to 225 plus. Now, I'm going to take you guys back to algebra. And I know that if this whole thing is squared, what I'm actually doing is I'm multiplying the same bracket by itself. So I'm actually going to have p minus 2 bracket p minus 2. And then I just have to do the FOIL method. I know by now we all know the FOIL method. Top, bottom, and we will get the answer. And what we're actually going to be solving for, guys, is a quadratic equation. All right, I'm going to pause here. I want everybody to take a screenshot of this last part that I've written over here, because this is where we're going to start the lesson on Wednesday.